Welcome everyone. How many people have done this fireside chat with Venkat at Christmas time before? Okay, so about 20% of the folks. So for those of you who have not done this before, the format is actually very simple. Come up with the hardest, most obfuscated question you can come up with and ask this gentleman here, and he will answer it for you, or maybe not. I don't know. We'll see how it goes, okay? So I'll introduce myself first. My name is Pratik Patel. I'm a Java champion. I live here, and I'm the president of the Atlanta Java User Group. So Venkat?
My name is Venkat Subramaniam. These days I say that I live on seat 10F on United Airlines. I travel a lot around the world.
That's business class, right?
No, actually it's economy.
Really?
That's where I am mostly, yes. For a person of my size, that's pretty comfortable.
Fair enough. Fair enough.
I live in near Denver, Colorado, and I speak in conferences. I write books.
Hold on a second. You live in Denver, Colorado. How many days have you actually been in Denver this year so far?
I think if I total all the days together, it comes to about 3 weeks.
Oh, out of the 49 weeks or so we've done so far. That's impressive.
Yeah. Well, at least that's where I pay taxes, let me put it that way. So I also part-time teach at the University of Houston. I've been teaching there for about 30 years. And I do consult, train, and mentor in different companies. That's basically what I do. Thanks.
Venkat has also written about 30 or 40 books on Java. How many have you written now? 50? 15, oh, okay. That's good. I was about to be really impressed. So Venkat is the kind of person who can start writing a book 2 weeks before Christmas and finish it by New Year's Day. That is not a joke. Is that right? Which one did you write over Christmas?
Quite a few.
Quite a few. Okay, there you go. Way smarter than us, right? Okay, so let's take the initial question. Otherwise, I'll just make something up. Who has a question? Chris over in the back row.
All right, so last week, some famous AI person went to Harvard and told CS entry that computer science is dead. Did you guys hear about this?
No, tell us.
Yes, I don't know. I just tried to Google the guy's name. I couldn't find it. Some AI expert showed up at Harvard Computer Science 101 class last week and told the students computer science is dead. You're a professor? I know I got quite a few people who were my interns and former interns who said, uh-oh, am I in the wrong industry? What do you think?
You know, actually, it's funny. We were just talking about this last week at Architecture Conference in Tampa. So anyways, go ahead. I'll let you go first.
Yeah, so how many times have we heard this phrase, something is dead? So here's the problem. AI is a fantastic tool. It will be. And it is a tool. So if you are ignoring AI, you're in trouble. If you think it's going to do everything that you do today, you're also in trouble, because that's not true. And the reason is, it is just a tool. And if the way I look at it is, let me put it this way. AI is doing to our field what our field did to the rest of humanity. And I think that's good, because it's going to make us more productive. It's going to remove the waste. It is going to automate stuff that can be done much more better than humans wasting time on. The beauty of a human, to me personally, is in our creativity. I think human life is wasted if we do mundane things that can be done by a machine. So if I'm spending my time 30 hours styling a CSS, that's not a good use of my human time. So will AI replace a number of people's work? I think it will, and it should. But it's also going to bring opportunities. This is the most beautiful things. And it's funny that people don't realize it. Most jobs that we do today did not even exist 20 years ago. And that's the beauty of humans, is we are adaptive, we are resilient, we have the ability to learn. And those who, as Darwin said, it's not the fittest that survive, it's the most adaptable that survives. So I don't like statements like something is dead. I would rather focus on what we need to do to move forward, and that is be, agile, as the true nature of agile means. That learn every day, make your mental muscle active. One of the things that, honestly, I'm 55 years old now. I felt the oldest when I was 30. And I wake up one morning like, my gosh, I'm too old. And if you ask me today, I'm like the kid in a candy store. Because to me, what I learned at 30 is that I'm going to be gone if I don't really continue to learn. And that's no different. And that's exactly what I look at today, is people who fear need to convert that fear to action. And the action is put your time learning skills that would actually contribute to your creativity. Don't learn skills that can be automated by a machine, because as a human, you don't deserve to do it. That's my take on it.
So Venkat, are you sure? I saw a job posting the other day that required 5 years of prompt engineering experience. So I'm just saying. But let's dig into this question a little bit, right? So when we think of the task that a software developer does today, what do you feel are some of the, not super specific, if you want super specific, but some of the specific things that will get replaced or augmented, or AI will become a tool to help you with?
So there are actually, I see this as very positive. And part of the reason I see it as positive is, one of the problems is to even ask the question, does this code work? And sometimes developers write code, and as an expert developer, you might look at the code and say, oh my gosh, there's a concurrency issue in this code. And the other developers are like, what do you mean? Well, AI can help you a lot in identifying problems like that sooner than later. Imagine as you're writing code, whether you're writing manually or with a tool, it's able to immediately give you feedback saying, don't go there. This is not going to work. That can be extremely valuable. So error detection can be very useful once it matures. It can allow you to optimize code. It can allow you to devise algorithms. So one of the phrases I've been using more recently is, use AI for ideas, don't use AI for solutions. And to me, what is really exciting about AI is, I throw a problem at AI, it tells me 20 things. And I say, whoa, I didn't even think of those 10 other things that you mentioned. So it's giving me ideas. I may have thought about those ideas in 3 days, but I'm able to think about their ideas in 3 minutes. And that is rewarding. Now I have a dozen ideas. As an expert, I can eliminate half a dozen of them. I can decide to focus on a few that deserves the attention. I think AI is going to be really, really useful in that case. So I look at AI as a way to find ideas, not solutions. AI can be really useful in scaffolding code to get us moving forward very quickly. So if you're trying to build an application and you have a really good idea, if you're able to specify really well, and of course ask the question, when was the last time humans specified really well? But if you're able to specify really well, you're able to then create the code really quickly, which means you can observe what you create, and software has the observer effect, and you say, nah, not quite what I wanted. You can reprompt it, regenerate the code much more quickly, so it can shorten the life cycle of developing applications. So there's a lot of areas where AI is going to make a big difference. What that really means is, it's going to leave to us that job of thinking deeply about the problem we want to solve. What value are we going to create for humans to use the products? If you can shorten the time to market your ideas, we can generate ideas faster. We can try ideas faster. This really accelerates delivering value quickly to the business, to the customers, to the people. So I think this is extremely positive if we can leverage that to the right degree.
Okay, we don't want to spend all night on AI, but one thing, when I think of AI, I took artificial intelligence when I was in graduate school many years ago, and it's extremely complex. And a lot of people are like, oh, AGI, basically general artificial intelligence, is just around the corner. Like some people say by 2030 or 2035. Do you have any opinion on that? Like how far are we from the singularity? And next up obviously is the series of Terminator movies, but.
It's hard to tell. And the reason it's hard to tell is what we are seeing right now is a lot of movement. I wouldn't place them as improvement yet. Part of the problem is if you look at the code that we, at least in the software development point, right? It's used in a lot of ways. My son has been telling me, Dad, point your camera at the food. It tells you the calories in the food. Things like that can be really valuable in terms of how we can use it. But from the code generation point of view, I jokingly say this, but only jokingly partly because it's true. We trained so humans wrote really bad code. We trained AI on code written by humans. Now we complain that code written by AI sucks. I call that karma, right? So that's kind of where we are right now. So I don't think I can assess what the future is based on that. It's fantastic. It's learning a lot of things. But what it is doing, it is throwing a lot of unpredictable things at us. So the reliability part is missing still. The trust and confidence I can place in it doesn't exist right now. So I don't think I can put a number on it based on what I know so far.
Right, and I think the other thing that we haven't talked about so far is if you use something like Copilot, what's the license on the code that's generated from it, right? This is a huge problem. There are companies already, like Apple, for example, they won't let you use ChatGPT or whatever for anything, actually. Forget about code, just even like simple stuff, because they're worried about, well, if you generate some code using Copilot, and because Copilot also sucked in all of the comments that were around the code, there's context, so you can actually say this code may have possibly come from here, or definitely has come from here, and that code is GPL or worse, AGPL. Now all of a sudden you have a huge problem because what's the license of the code that you're actually building or creating, right? Is it license compliance, or do you have to open source everything that you own or generated in this project?
What I'm reading from what you said is there are a lot of attorneys having a great time right now because honestly, this is a field day for attorneys because we just opened up the door for them and said, go. And I personally served I've served on about maybe 3, if not 4 lawsuits so far over the past 3 decades as a witness. And the most recent one, not related to AI, but comes pretty close to the idea that you're suggesting. A developer took an open source product written in Java. It's open source, yes, but completely rewrote it in Scala and made changes to it. And so the company that was responsible for this open source product came to me and said, well, you know Scala, you know Java, here you go. Compare these 2 source code and tell us how similar this is. Can you make the claim that this code was copied from our code and then evolved into a different language? And that's going to be the case more and more. And it's not about a company thinking what they are right, it's what they can prove in the court of law. And when attorneys, so you and I spend time writing code, attorneys spend time trying to find how to get money out of it.
Oh, okay, so they're the ones actually reading code then, huh?
Or at least have somebody else read the code.
Somebody else read the code.
And that's the problem, right? So the risk is enormous on companies when they're using code from others because you need to be spending the time in the court defending for the code you used. So the time and effort you saved in writing the code is going to come back to where you pay the money for the code you used. That's a high risk. I think companies need to, this is one of the reasons why some companies I know are only training their code on their own internal code and not external code. I think that is a smart approach because if you're training this on your own code, you don't have the liability that you may have for copyright violations potentially. So it's worth thinking about it.
All right, so let's move on to the next question. Who's up next with a question? Oh, there's got to be somebody. Okay. Over here, Tony up front, right here.
Regarding quantum computing, which features a language should have or what do you think? What do we need to go to a new paradigm of using the potential of quantum computing?
Okay, so repeat the question.
So the question is, what do we need? What languages, I would assume, right? So what do languages need to reap the benefits of quantum computing? I actually have to say I don't know the answer for that. I haven't thought much about it in that area. Sorry. Yeah.
He stumped the genius. Sorry.
Coming back to Java now, so from AI, let's switch gears a little bit. So Java, like with 121 out, so that's most of the like excited features like Amber, Loop, they're all like general available. So what are you excited next now? So what's like 22, 23? What are the key features you are most excited about, and like why?
So just to step back a little bit, so the question is with Java 21, we got many features already in Java, especially Project Loom and things like that. Moving forward into the future of next few versions of Java, what are you excited about? I want to step back a little bit before I talk about the forward. I do want to emphasize that the impact of virtual threads is going to be huge in my personal opinion. It's going to be so...
Hold on, let me do a quick kind of virtual thread. So if you're not familiar with what virtual threads does, is in the last few years, there have been libraries like Spring, Project Reactor, and Vertex that allow you to write in an asynchronous fashion so that you can get a huge amount more utilization out of your existing servers, basically compute. So a good metric that I use for that is that you could take a standard Spring application that is written in just the normal Spring style, and nominally you could get about 1,000 or so concurrent requests pushed through that instance. If you were to rewrite it with Spring Reactor or with Vertex, you can now have 7,000 concurrent requests going through it because you're now programming in an asynchronous style, and virtual threads will allow you to
scale, basically, right? So that's kind of the main benefit. I'm going to say, virtual threads is going to do to servers what Java 8 did to programmers in terms of productivity. We are able to use fewer servers to scale our applications. And that's going to be huge because with extremely minimum change to the code, you're able to handle a vast more number of requests. That's a benefit to companies because you don't have to deploy as many instances on the cloud for the sake of scale. You may have instances for availability, but I would argue you need fewer than what you need for scalability. So that's going to save your cost in deployment. It's going to make a huge impact on the environment. We don't have to have as many servers running. So that's huge in terms of the carbon footprint that we create. And so overall, I think that's going to be huge. And it may be another 5 years before we truly see that benefit, right? Because it's got to ripple through the infrastructures before we can reap the benefit.
Well, people have to get to Java 21. Step number one, get to Java 21.
Right. Well,
Actually, let's poll the audience real quick, if you don't mind, Venkat. How many people are running? I'm going to go from high to low. Okay. How many people are running Java 21 on production already? Okay. So one person so far. 17. Okay. So that's about half the audience. Okay. 11. If you raise your hand for 17 and keep them up, it's fine. Or if you're running stuff in 11 also. Okay. 8. Okay. A few people. Should I keep going down? Okay. 7. Anybody running 7? 6? Okay, well that's good. At least people are on 8 and above. So, anyways, continue.
Yeah. So that brings us to, where Java is moving forward from here on. So one of the things that I like about Java is they're not infatuated by change for the sake of change. That is very important because if they start changing the language rapidly, that's going to be a big problem. So one of the things they're doing very carefully is they're asking the question, first of all, are things feasible? If it's feasible, obviously it's worth considering. If it is not feasible, it's not worth trying to explore more. This is where I think languages like Kotlin, Scala, OCaml, Brian Getz was mentioning that in a blog post a couple of days ago. A lot of other languages are influencing what is feasible. And just because they're feasible in those languages doesn't mean it's automatically feasible in Java. So that's feasibility. Second is it truly useful? Something can be really esoteric and like, ooh, that's nice. It's an eye candy. But is it really useful to a day-to-day developer using Java? That's the second thing they're looking at. But a third, more intriguing thing, and Brian Getz was asking this question, I thought this was a useful question to think about, so I'll ask the question to the audience, and let's see if we can think of this. What feature that was in Java already that made it extremely hard to implement other features? So what feature in Java made it really hard to implement newer features in Java? Serialization. Exactly. That's the hard one. Because serialization is so innocent when you think about it, right? How cool it is. You can just take an object and you can serialize and deserialize it. Lambda expressions were delayed a lot because of serialization. Lambdas are serializable. And you're like, why? I was working with a client and I said, wait a minute, you're taking a Lambda and you're using serialize on it. And they said, yeah, Lambda is serializable. So we actually take a Lambda and use RMI and send it. I'm like, you guys are the culprit who delayed Java, right? So there's at least one company that has a use case for it.
I was just about to ask you, does anyone even use serialization today?
Yeah.
Apparently one company does.
I had a client who did. I was actually quite shocked. They were actually using that to literally take Lambdas and serialize it across port and run it on the other side. Don't even ask about security, right? So, so the point is, so the last concern, the feasibility, usability. The third is, how does adding a feature impact future modifications? That's an extremely hard question because most people are eager to put stuff in, but they don't ask the question, what have I done now? What is it going to make worse in the future? And this is a battle that people like Brian Getz have to deal with every day. I was speaking in a conference a couple of days ago, and one person said, but what if Java had just, and this is the word just that Brian hates the most. What if they had just done this? Well, the problem is, as an Armstrong programmer, I can think of a lot of just, why not just do this? But as a language implementer, it's incredibly difficult to implement things because you need to deal with the consequences of what you do. In my own experience, things that I feel like are extremely important for Java to have, and thankfully they're working on it. The first one is value types. Value types are incredibly valuable because I was working on an application where we clocked in about 53 billion computations. That's what we were doing on every call. It was a big data project. A request comes in, 53 billion computations. We took a small subset of the problem and we wanted to parallelize it. So we put the effort, parallelized it. We're like celebrating. Yay, we are awesome. It took 30 minutes to run. We brought it down to less than 5 minutes and we can keep going. So then my partner who I was working with, my colleague, he said, well, good job, Venkat, this is great. Let's throw this on a real problem and see how it goes. We throw the same code we wrote, rather than a small data set, we threw it on a real problem. Runs for hours. We're just sitting and staring at it, like what's going on? And then after wasting about a few hours, we couldn't really find out what was causing the problem. We started timing the functions. They were super fast, much faster than they were. So after struggling for a long time, I said, wait, let's just turn on the flags to see what the garbage collector was doing. That's when we found out the garbage collector was spending 20 minutes on garbage collection alone. And we were in a state of shock, panic actually, because what we found out was we had double with a big D because we had list of doubles and maps of stuff and double. So every double was being auto-boxed. And so the garbage collector had a lot of garbage to collect. This is the problem value types are going to solve. Value types are objects you can create on the stack rather than on the heap. So when you leave a function, there's automatic garbage collection, instantaneous automatic garbage collection, because what's on the stack is thrown away when you leave the stack. So imagine creating a list of integer, but they're not on the heap, but they're going to be on the stack, because integer can be a value type. So, but it's an easy problem for me to talk about. It's an extremely hard problem for them to implement. Brian and the team have been working on it for more than 10 years now. So that's going to become a reality eventually. So that's one thing I'm really looking forward to. Reification of generics is going to be another big area where you are able to make better use of generics without the problems we have with generics these days. So there are very hard problems they're working on. More so into, we already have some amazing features. One of my most favorite feature right now is the concept of destructuring.
I was going to mention closure-style destructuring, but go ahead.
Yeah, and I'm a guy who gets excited too quickly. I was working with Kotlin and JavaScript one day, and I tweeted that day saying, today's tweets are sponsored by destructuring. And Brian replied back saying, I will neither confirm nor deny if Java will have destructuring. And I said, I already know the answer now. I can't wait to have it. This was 5 years ago or 4 years ago. And we already see a lot of destructuring in place. So you could destructure records. You could destructure nested records. But now the question is, okay, we can destructure records. But for those who are wondering what destructuring is the opposite of structuring. So if you take properties, you can create objects. Imagine the opposite. You have an object, you want to tease apart the properties from it in a much more elegant syntax. So if I have a stock object, let's say I have a ticker and a price, I can say, using a case in a switch pattern matching, I can say stock, get me the ticker, get me the price. You have a local variable called ticker and price that extracted the value from the stock object, for example. But imagine taking that idea of destructuring, but doing it for any class, not just records. So Java is going to have a deconstructor in addition to constructors. So just like how you write constructors, when you write a class, you can write a deconstructor. And the deconstructor will teach Java how to take an object and tease apart properties from it. So it'll take what you can do with destructuring for records to general classes in the future. So those are some of the interesting features that you can see that are going to emerge in the next few versions that are going to provide really useful values to impact performance, because that's extremely critical, because when you're using Java on big data projects, you don't want to be smashed by garbage collector like that. You can optimize garbage collector all you want, but if you're creating more garbage, you got to collect more garbage. So the place you want to stop is creating garbage. Value objects are going to make a big difference for that. Destructuring makes us more productive. So things like that are going to make a huge difference, I think.
Okay, great answer. Next question. Anyone have any follow-up thoughts? No? Okay, there's got to be some way. Nobody wants to ask about Kubernetes or something?
So what else besides AI has been interesting this year to you, or intrigued you? We've been focused so much the last 6 months on, oh my God, AI. There's other stuff happening, right?
Right, so the question is aside from AI, what else has been interesting for you, Venkat?
So AI is interesting in its own for various different reasons, not just because of the hype cycle that's going on. But as I mentioned earlier, honestly, virtual threads has been really intriguing for me. Virtual threads is going to make a big difference, but also from the point of view of understanding what the consequences of that is. One of the things that people said I don't agree with at all is that they said reactive programming is going to be dead because of virtual threads. I beg to differ. I don't agree with that. The reason I don't agree with that is, to me, reactive programming means two different things. Reactive programming means that you're able to do asynchronous programming. To me, that aspect is dead. I agree with that. But that's not reactive programming to me is. Reactive programming is really using back pressure. There's a use for back pressure no matter what you do. So the reactive programming with back pressure is still valid. What people are not talking about, unfortunately, is completable future has no future. That's my statement. Because if you look at how do you do asynchronous programming in Java, right now your option is to do completable future in Java 8, introduced in Java 8. But the problem with completable future is you're writing a functional pipeline. The problem with functional pipeline is that it's great when you have pure functions. But if you have exceptions, it's horrible to write code with completable future. So the reason I'm excited about virtual threads is, in addition to the scalability, it is really resetting the playing field. You can write imperative style code where the structure of your synchronous and asynchronous code are going to be the same, and you don't have to modify your code to go from synchronous to asynchronous. That's going to be huge in terms of our ability to modify the code. So that definitely is very exciting for me. So from that point of view, virtual threads are just absolutely amazing. That's something that I've been very excited about in the Java ecosystem in general. Other than that, I would say, watching language developments, language development in Java itself is very fascinating. I just saw a blog post by Brian, for example, talking about how can we make exception handling a little bit easier in functional style by using pattern matching for exceptions. They are seriously learning from other languages like OCaml and such, and then bringing ideas that are relevant into the Java ecosystem. So that to me is really exciting. So I'm excited about that as well.
So I'll jump in here with a couple of thoughts here. I think one of the things that's been keeping a lot of developers who are new to the Java ecosystem or moved off coming back is that Java is slow in startup and it uses a lot of memory and CPU at execution time, right? So at least I think we're starting to solve both those problems. There's something called CRAC. It's an OpenJDK now. It's basically fast startup for Java applications. It allows you to take a checkpoint once your app is started up and all your Spring Boot or whatever stuff is loaded, and you can start it instantly, 2 orders of magnitude faster. So a Spring Boot application that normally would take, let's say, 3 minutes to start, can start in 300 milliseconds or 30 milliseconds. So that's one big thing, especially if you're deploying into cloud-based models like Cloud Functions or Kubernetes or containers as a service or whatever. The other thing I think that's really interesting is a project from Spotify called Backstage. Has anyone heard of Backstage? Okay, so do you know what Backstage is? Have you looked at it? Okay, so Backstage is the best way to describe it is it's a developer portal for your company. It does a whole bunch of things like docs as code. It allows you to do automation, things like that. It's an open source product. And so when I think of what makes developers work in a better way, makes them more productive, when you can start something up much faster on production or even on your desktop, that's a huge win. If you can have a way for a larger team of software developers to be able to not write as much documentation, have more automation around their entire software development process, that lifts everybody on the team up in terms of productivity. So those are the two things that I'm keeping my eye on. So the Backstage is kind of newish, but it's been in development at Spotify for years and years. So it's not like a brand new thing. So if you're looking for something to introduce to your team and look like a rock star, go look at Backstage from Spotify. Again, it's open source. So, okay. All right, more questions? Oh, VP.
Hey, Venkat. This is my question on, I know we have discussed this problem about streams and exception handling. So do you think in future, like in Java 21 or above, is there anything like which has the data stream, error stream, all that goodies that we've been thinking about having in Java? Right now, I know we can use completable futures and other things, which is like, unless you are advanced programmer, you don't tend to use those. Like for me, I have a lot of juniors in my team. They start with the streams and they start writing code with the stream, especially when there is a problem or an exception that they make a downstream API call. That could be an exception or a 500, how to handle it, right? They have no idea about how to handle those exceptions. Now, either we have to break that from streams to a normal classic structured program and make it try-catch and teach them all that. Rather, in future of Java, do you see anything that would help us getting those features within the Java itself?
I think it's a little too early to say, and there are a few ideas that are being experimented right now. and we quite don't know where it's going to go. It's a little too early to know for sure. But this is a problem that is in the top of the mind of a lot of people. And it's also a hard problem to solve because there are some few different ideas that are floating around in different languages. There are a few ideas in Scala, for example. There are a few ideas from like OCaml, for example, that's being explored. There are a few different people who are part of the Oracle team right now who are also experimenting certain solutions. It's really too early to say where it's going to go. Will there be an answer in the next 5 years? I'm a little bit more confident now than I was a year ago. So yes, so I think we are heading in a direction, but it's too early to say where things are going to go. There are a few solutions today, right? So what can developers do today? I say this honestly, sincerely, that it's not a bad idea to fall back and write code in imperative style. The reason
I'm sorry, what?
Yeah, absolutely. Absolutely.
Are we recording this?
And the reason is, so the goal should be to solve problems, right? I always say, you're not in a competition. You don't need to prove to anybody that a code is in a certain style. The key is to be able to solve the problem effectively. If your problem is a lot of pure functions, it makes a lot of sense to use functional style. But if your code is impure, getting it correct is more important than showing off that it's in a certain style. So I actually recommend writing code in imperative style, especially virtual threads are shown as that, right? So it's a pendulum, and the pendulum is shifting on the other direction, right? And the direction is, yes, it's great to write functional style code, but when it's not really giving you the benefits fully, you need to fall back to writing code in a way it's manageable. So that's not a bad idea. That's what I would tell developers today is don't force yourselves to write code in functional style when it doesn't fit in properly. Because ugly functional code is worse than a better imperative style code. So that's what I would recommend as of today, until we know better in the future.
All right, so while you guys are thinking of the next question, let's take a quick survey. How many people are Java developers in here? We'll start the easy one. Okay, that's everybody. Okay, great. How many people are using Kotlin on production? Nobody, wow. Anybody doing Scala? Wow, this is the first. Usually at least there's a few people who are using. What else should we ask in terms of programming language?
Python, obviously.
Python, how many people are using Python? Okay. Is that just for machine learning or just for general purpose apps? Okay, so it looks like it's a smattering of one of those two, huh? In JavaScript, of course, everyone probably has someone on their team or part of their team that's doing JavaScript. Okay, that's interesting. In terms of the JVM languages, it doesn't seem like...
Groovy, I would say. Groovy.
Anyone still using Groovy? Oh, wow, okay. What's that? For writing tests. That's close enough. Production, you're testing production code. Is that what, Burke, you're also using Groovy? Using, not Cucumber, what's it called? Spark. Okay, yeah. Spark. Same for you? Okay. Interesting. I thought that at least Kotlin would have a little bit more traction in the Java universe, but I don't know, maybe it went through the hype circus, whatever, the hype curve, and it's back down to just back to Java. So actually, while you're thinking of the next question, let me ask Venkat. Oh, is there a question so far? Oh yeah, let's go to the question. I'll ask my question later. Right there, right there.
Hey, Venkat, back to the GitHub Copilot question related a little bit of AI there. So you did mention some legal issues about GitHub Copilot recommending some code and using it, right? Most of this Copilot LLMs are based off some code, right? Do you foresee any legal issues in the future? I know most developers do use Copilot, right? If a code is recommended and we use it there. So do you foresee any legal issues in the future that, hey, this was kind of similar to a code that was matching something, but it's something Copilot has recommended, right? Like, so, because it would have technically taken it from some open source, or it would have by default trained on some model there with an existing data. So do you foresee some problems like that with GitHub Copilot there?
I do. Pratik was mentioning that.
Yeah, we talked about this already before, which when they essentially created the model for Copilot, they literally sucked in everything from GitHub. Which, how many lines of code would that be? I don't know, probably trillions or multiple trillions of lines of code. I don't know, lots of code, right? What's that? Trillion, yeah, who knows? A huge amount of code, right? And so I mentioned earlier already that they didn't keep track of, is this GPL code or is it MIT or BSD or Apache licensed? Is it AGPL, which is the worst kind of license if you want to commercialize your code base on some open source project? So anyways, we mentioned this already. The short answer is that, as Venkat noted, lawyers are going to be making a lot of money over the next few years. So
the bottom line is this. A company can say whatever they want to say, but that doesn't mean anything in the state of law. The courts will evaluate it based on what they feel as the merit. So what I would ask teams to think about is evaluate your own risk. That's what you need to be doing, because at the end of the day, your company is the one that's going to be answering the question if they get sued. That's the point, right? So GitHub can say anything they want to say, but are you going to put every faith into them to say, you guys said this, so we are good? If your company gets sued by another company, which can show that the code that's in production in your company, here's where things can get a little interesting. You may have an employee who is disgruntled, they get laid off, they get fired, they know that they've been using code in a certain way, and if they're able to show to somebody saying, hey, look, in my company, this is the code we are using, and if they can connect it to a code from another company which has bigger pockets as well, then their attorneys are talking to your attorneys, and then the question is, what is the liability for your company? This is not a discussion I personally think that I need to have as a programmer. It is a discussion that my lawyers need to have with my C-level people to understand the risk of what they are doing. Because this can have a huge impact, and when companies get sued for millions and potentially billions later on, it's not going to be you and me who is concerned at that point, right?
Yes, definitely makes sense, because even in our companies, we are trying to evaluate those, so I think that's the right thought to take and relate it down. Hey, think about this in that perspective, right? It's just that the free open source tool that's good to use, we need to think about the legality of it, right?
Definitely, yeah.
okay, is there more questions? Just got plenty of time. So up front, Glenn, right here.
So Venkat, continuing on the AI track again.
No. No more AI questions, please. Let's do something else. Okay.
So I mean, as you know, AI is always linked with hype and the real value.
Oh.
How do we differentiate what is hype and what's real value? So I will give you an example. Bloomberg, few months back, they said they're going to create articles with AI's help and they're going to fire 30% of their employees. Their stock jumped like anything, and then eventually when they didn't deliver, it tanked. So when you look at a company's release, or when you look at a company which says, okay, AI powered, AI enabled, how do you differentiate what's real versus what's hype?
Let me jump in here with an answer. It's all bullshit. I'm only being somewhat sarcastic, but please, Venkat, you give a more nuanced answer than me. I'm selling all my NVIDIA stock. Anyways, go ahead.
So to me, the hypes are anytime clickbaits, overarching statements, are statements that are trying to tell you that this is the end of something or everything has changed.
Blockchain.
And so the hype to me is when we try to cause anxiety and fear into people's mind. That's what a lot of these things are. But this is not new. If only we were the fly on the wall, and we can go back to the time of when computers were being introduced, or when Industrial Revolution was happening. This is not any different from that. I was thinking about this the other day. I was traveling and I saw 20 people desilting a lake. And this is intense labor. They are sitting there, there's one person going in, digging the soil, passing it down, and then a couple of weeks later, I saw 300 people on top of a train tearing it apart. And then I see one guy, in another place, standing there to make sure nobody comes near, and there's a guy on a crane pushing a button and moving things. This one person, two people, one hardly doing any work than keeping people away, one person on the top pressing buttons to move things around, replacing labor of 20, 30 people, right? It makes sense that we need that kind of people to do the work in some places, but we also need the productivity. But the guy who is pressing the button, we all can immediately tell is more skilled than the person who's doing the manual labor. If the person pushing the button presses it wrong or is negligent, more damage can be caused. That's the state we are in for our own field. So when the fear is caused, the fear is natural. That's human reaction to things. Those are, to me, hypes. Hypes are there to induce fear, to induce anxiety, to disrupt what you do.
Pump up your stock value.
And to be beaten by it when it goes down, right, eventually. So we got to be careful about it. But it's also important not to think of these as hype and ignore them. That is the biggest fallacy, right? If somebody is fearful of this and react to it negatively, that's bad. But if somebody says, oh, this is all hype, it's never going to do anything, I am to a point where I'm close to my retirement. But I've got children who are just starting the workforce. This matters a lot to them than to me. And because it matters to my children, it matters to me for that reason, right? So this is going to impact the next generation a lot more than the current generation. If you are financially dependent on the current market, that affects you a lot more as well. So these things matter a lot. But the key is to really separate those hypes and say, we are not going to have anything drastically change in 5 years. I can tell that. But 5 years is a long time. But in 5 years, we're going to see significant differences in what we are going to see. So the question really is, to me, is not as much about the separating the hype from the reality, but it's a question of how can we prepare for it. That's always the question in my mind, right? How can I prepare for it? And every time I look at it, I want to separate all the noise from the signal and say, here is what I need to be focusing on to leverage this tool really well. And if we look at things that are available in our field, what we do is, I would say, there's part of what we do is very intellectual, and creative. Part of what we do is very mechanical, you're updating configuration files. You are trying to get things.
YAML.
you're trying to get things to deployment. You're trying to write an automated script properly. You're trying to write automated testing. Don't get me wrong, I'm a huge fan of automated testing, but I never lose sight of it. My goal is not to write automated testing. My goal is fast feedback loops. I use testing only because I don't know of a better way to do it. If AI can give me a way to get a better feedback quickly, then I have to write automated tests, I'm jumping on it. Because my goal is not to write test cases. My goal is to get automated feedback. So that's what I keep processing every day, is asking the question, what are the values that I want to focus on? And how can I leverage the tools that will get me the results I want? As long as we are able to do that, I think we don't have to worry about the hypes. And we are able to discern the noise and then distill it to the signal, and I think we can be more productive.
All right, so let's take a quick poll here, and this is the last AI thing, by the way, okay? So there are about 70 to 80 people in this room. Now, don't think about how you're using Copilot or other tools to help you with the actual software development process. Think about the business application that you work on. How many people are actually working on using AI as part of the businessy part of your application? Not me, I'm just putting my hand up. Okay, So VP, I'll pick on you if you don't mind, if you can tell me, right? And you don't have to kill me afterwards. What is it that you're actually doing? Here, I'll give you the mic. Well, what is it that you're actually doing to use AI in your business application? Again, not to help you code, but as part of your actual business.
So payroll processing is part of it, and we're planning to get AI assist into it, basically suggesting users on when next things has to happen. All those suggestions are getting.
Okay. Where did the other mic go? Okay. Yeah, go ahead.
Together.
Oh, okay. Did he say what you were going to say? Sure. Okay. There was one other hand, all the way in the back, right behind you, and go all the way to the back first, Glenn. Oh, never mind. Yeah, you go first. That's fine. Then we'll go to the back. Yeah.
We use it for in our support processes, right? So we've got a ton of tickets that come in. We look at the tickets when we've used ChatGPT to go sort of mine the data and pull back and see what kind of questions have been asked in the past, and then drive agility in that process. And that has significantly helped us.
Okay, so you're basically building an LLM to do what you're doing. Venkat, what kind of model are you building? Is it LLM or a different kind of a machine learning model?
OpenAI.
Right, right, I got you. What about you? You're not sure? Chris, do you know what it is?
That's an LLM.
It's also an LLM. Okay. I think there was one other person, right, that raised their hand?
Yeah, and I'm into an e-commerce world there, so we do use AI for the search, like to identifying what the customer is really searching for. Like if I say
Okay, so you're using AI for predictive analysis. Is that correct?
under vector search, yes.
Yeah, okay, and vector search predictive analysis. Okay, gotcha. Okay. Right, so we have one person out of those examples that's not using an LLM, which is right there. So out of 70, 80 people. Okay, there you go. All right. Next question, next question, go ahead.
So I liked your whole comments before about not wanting to test and things. What do you think of Open Rewrite and those kind of technologies that are looking at a code base that people may not have looked at for, probably not 20 years, but maybe like 10 years, and are now going, hey, I got to get that to JDK 22. What do you think of that approach?
I think that's absolutely great. The reason I think they're great is, for exactly the point you mentioned, the code, unfortunately, doesn't tell us the story of what's hidden inside of it, oftentimes. What was the programmer thinking when they were writing the code? So if I'm going to be writing the code into a different language, there's a huge risk of me missing a lot of stuff that may be intended, but I don't really catch it. That's one problem. The second problem is, if we, and that's a very big if, we have really good automated testing, we can run through the code after we create a new copy and verify if it's still working, but that requires porting the code over, but porting the test over as well. That's a huge cost. One of the biggest problems for a lot of companies today is finding people who are going to be willing to write code in an older language. That is incredibly difficult. I'm talking maybe 15, 20 years ago, companies like IBM came to the universities and said, we want to find those faculty who are not yet dead, but know COBOL really well. We're going to pay them a lot of money so they will start offering COBOL courses again. It didn't go well because some professors may be wanting to come back from death and start teaching those courses, but the younger kids never wanted to really go back and take those courses. That's a problem that you're going to have moving forward, and tools like that can help businesses to untangle. If you look at software design and architecture point of view, there is one thing that is very important to consider from the design and architecture, which is the concept of reversibility. Reversibility is your ability to back out of decisions you make. In almost every aspect of life and design, reversibility reduces the risk for us. I make a decision today. I purchase an airline ticket. I decide not to fly to that city. I decide to cancel the ticket. If the airline charges a fees, that makes my trip expensive. If the airline says no fees for you, you can rebook the ticket to another destination, that decision is more reversible. Libraries are more reversible. Frameworks are incredibly hard to reverse out. Languages are the worst because once I commit the code to a language, I cannot reverse out of it. Tools like this break that reversibility cycle and says, no, there is an escape route. And that's why those are very, very valuable tools if we can make sure that they work properly.
So quick plug here. The Open Rewrite people, folks from their company, will be at DevNexus offering a full-day workshop on how to use Open Rewrite. So if you're looking to migrate from Spring 1.5 to 3.2, you can do that with Open Rewrite, and they'll show you how to do it. So sign up for that workshop. All right. More questions?
So my question is regarding coaching and mentoring. You mentioned that you have been teaching for 20 years now. Let's say if you have to give an advice to an undergraduate student who's just starting his career in computer science, how would it differ from what you would have said 4 or 5 years ago?
Not very different, 4 or 5 years ago, that is. And the reason I say that is some of these are so fundamental to what we do, and yet we do it wrong so many times. This is what I would say for not only a young graduate student, but also a young employee as well. Be shameless. Be absolutely shameless. Part of the problem in a lot of people is we feel like we should know a lot, and so we don't quickly admit that we can learn from others.
Well, there's a word for that, isn't there? Does anyone remember what that's called? Where like you think you know? Anyway, sorry. It's not coming to me. But there is a phrase for that or a word. Anyways, go ahead. Sorry. No, it's not imposter.
No.
I think it's the Dunning-Kruger effect. But anyways, go ahead.
Yeah, Dunning-Kruger effect is where you think you know.
That's right.
But this is, you don't know, but you don't want to admit you don't know, right? So I always quote Newton's words. Newton said, I see the farthest because I stand on the shoulders of giants. We got giants around us, and make use of those people. If you're a graduate student, or if you're an undergrad student or a young developer, collaborate. This just blows my mind. When I'm in Europe, in Western Europe, one of the things I always do in my classes is when I teach courses in the industry or a workshop, I tell people that I want you to pair, and I want you to rotate pairing. It's a culture somehow we got into this culture. In Western Europe, I will have to tell them, we're going to pair and rotate pair just once. Within minutes, people are moving around the room. In the US, I have to beg people. Literally, I have to beg. And after enough begging, about 50% will pair. The other 50 are very reluctant, and 20% will never pair no matter what you do. That's a problem in our culture somehow, that we want to be in isolation, because if we collaborate, we learn more very quickly. I remember the first day I walked into my professor's office, I watched him just type on his keyboard. And I said to myself, I want to be like him when I grow up. Because it's inspiration to learn from other people. So go to a colleague and say, hey, I wrote this. What do you think of this? Can you review this? The amount of feedback you can get from them is just absolutely amazing. So be shameless in asking for reviews, asking for feedback, asking others to collaborate with you, ask them to pair with you. I think that is one thing we are missing out a lot in our industry. If you look at other industries, doctors cannot work in isolation. That's not their job. My wife and I decided to redo the bathroom because we have elder parents in the house. So we tore apart the bathtub and put a walk-in bath. So I was home, this guy was fixing, redoing the bathroom. And I went to him and said, I'm sorry, but I'm just curious, I need to ask you this question. You're really good at what you do. Can I ask you how you got really good at this? And he was 20-something. He was not an old guy. So, and he kind of laughed and said, well, thanks for your comment, but all the credit goes to my, the person that I worked with. I did apprenticeship with him, and he it pretty much tortured me every day in terms of making me work. And everything I know today, I learned on the job by doing it with him. That's one thing we miss in our industry because we don't collaborate as much. That's what I would say is be shameless, just collaborate a lot.
Yeah.
I have a quick to that about the interns.
Please.
If you're at a company and you have the opportunity to influence getting interns, do it.
Yeah.
To the growth point. But also advice to a young student, there's nothing wrong with nepotism to get your first internship. Shamelessly ask anybody and everybody you know, do you know anybody who's hiring? And get in there as quick as you can. Because that's how we grow the next generation. We can't just wait for them to come out of school thinking that they know stuff. Let's get them early, get them trained, get them to think the way you just described.
I want to dovetail on that and also say when you come to like a conference like DevNexus, especially like, okay, I'm a student, I can't afford volunteer. Because I guarantee you, if you volunteer and you sit up front and you're helping register people and you start talking, you build those connections that creates that nepotism. Because you may not know of a person, you may not be hiring, but you know that that person over there is. So build the network.
Yep. How many students or interns do we have in the house today? Okay, we got about 4 or 5. That's good. There's a question over here.
Well, that still blows me away. Georgia Tech and Kennesaw State don't have a lot of young people here every month.
Yeah, I agree.
I had access to this when I was that age. My gosh, how much stuff did we just learn in the last 30 minutes?
Right.
Hi, I have a question. So 10 years back, we have a lot of web-based user interfaces applications, and now we see a lot of mobile-based user interface applications actually. With the rise of lot of chatbots and other things where I don't see a use of web-based application or a mobile-based application where user can just type in SMS or do some, perform some operations actually. So whether the UI-based applications are going away, and these two are well supported by Java-based languages. Basically, the web-based, browser-based applications and the REST or other APIs are well supported by Java. So how does your the future of Java is supporting IoT devices and other external devices like chatbots or other electronic devices like that? Do you see like how it is competing with Python when compared to these type of devices? Because when compared to Python, where we can see like a lot of like with camera and other things and all, right? Like it can feed a lot of IoT devices, take the input and process it quickly with the ease of program. So basically, I'm from Java background, but can you just give us more clarity on the future versions and related to that?
So let me restate his question real quick. So the question is we've had mobile UIs and we have web UIs and conversational UIs are on the rise right now. So the question is does Java support those next generation type of things like conversational UIs, and what will be the next generation after that? That's the question. Is that right?
Not only the conversation.
No.
If SMS, it can perform an operation like before I have to use a browser-based URL to feeding
Yeah.
and or a mobile-based app to getting some input from the user. But now the users are more interacting with just SMS or.
Right. So when you talk about SMS or something like that, that's what's called conversational UI. Yeah, that's that entire spectrum is covered by conversational UI. So anyways.
So there are maybe 2 different aspects to it. I think it's worth exploring. So I'll take the easy one first and then a little bit more into the technology next. As a developer, I always say your strength is in diversifying your knowledge portfolio. The biggest risk you're going to run into is knowing one thing really, really well. Because the more you know one thing really well, the harder it is to adapt to other things. So diversifying our knowledge portfolio is extremely important. So if you want to go learn Python, you want to go learn other languages, I would say definitely yes. That's extremely important to do because the more you know, the better you communicate with others as well. If you find that Java is a better technology, you cannot have that argument if you know nothing about Python. That puts you in a weaker spot because that's called bias, that's called ignorance. So by knowing something more about other things, You're able to help people make better decisions to the languages you think are right. So that's something we need to really do. So I want people to learn more things because they can make better decisions, right? More informed decisions. Having said that, Java itself is not a great language for the front end per se. But Java's strength really is in the back end. It doesn't matter whether it's a conversational UI or something else, you still need to hit the back end. And when you hit the back end, you still need to get the data from there. So that aspect is going to continue, right? That aspect is going to be there. Whether it's mobile or web or conversational UI, you need to still work with the back end, whatever that back end is. So there's a lot of what you do that will still be useful moving forward. But having said that, we are at a point where we don't know what the front end is going to be yet because there's no unification of technologies on the front end. JavaScript is the weakest link right now. I don't think it's sustainable in the long run. You got WebAssembly, which has potential. We have to see what WebAssembly is going to be. If it's WebAssembly, language is not a barrier because you can write code in many languages for WebAssembly. So in a way, WebAssembly gives you it resets the playing field. It says, use the language you want to use. Hey, I want to use C# to build the front end. I want to use Java or Rust. Go for it, doesn't matter, right? So that's another benefit of the technology as it evolves. A little too early to say what it'll be, maybe another 3-4 years before we know it. But having said that, we are going to see this evolution, and we should. Conversational UI is extremely critical for a number of reasons. It's not just the ease, it makes it possible for a group of people who don't have the mobility to use a traditional API. We were talking about this, my wife and I were talking about this a couple of days ago. Young parents pushing the stroller on one hand, has phone on the other hand. We live in a very different world. How do you make it easier for them to use the application they desperately need access to while they have a baby they're pushing on the stroller? We need to rethink about usability, right? And then the question is, how can we as developers adapt to the usability that the users need, not want, right? They need this. And so then the question is, what kind of libraries we can use? And will Java play a role in it? It depends on the technology that makes those interfaces possible. I don't know. I don't think we know the answer today because that market is not mature enough for us to understand yet. But if you diversify your knowledge portfolio, I think you're in a much better position to deal with it in the future.
All right, Glenn. Let's take one more question and then we'll wrap up today. Up here on the top left.
Food as well. There's more food in the back.
Yeah, there's more pizza in the back if you want to grab a slice while we're closing down here. So.
Hey, Venkat. I was going to ask, what are your thoughts on Kotlin multi-platform and having one code base shared between two different platforms?
So repeat the question, Venkat.
So what are the thoughts on Kotlin multi-platform and sharing one code base across multiple platforms?
So this would be like using standard Kotlin on the back and Kotlin JS on the front, for example, or Kotlin in the Android or whatever. Okay, got it. Yeah.
It has a really good potential, but I wouldn't put all my faith into it. And the reason I say that is that the environments are still quite different from each other. The problem you often run into is when you try to provide a single solution that works everywhere, it's not optimized anywhere. And that's one of the problems you're going to keep running into. So if you're a small business, you don't have a lot of budget, you want to get a first version out running, that's fantastic. But if you have a very strongly established product, you want to provide a really good experience for the users, I wouldn't really focus on one code base that works everywhere. Having said that, there is a benefit to reducing the number of languages that we may have to use. So if you have two separate code bases, for example, but both code bases are written using Kotlin, for example, then there may be benefit to it because you can have programmers go back and forth much more easily. They need to learn the libraries that are different, but the language is still the same. So there may be benefits to it. I would say I have a mixed feeling about it. I'm not convinced one way or the other where This is great. No, I cannot say it. This is useless. No, I wouldn't put it in that category as well. I think it's somewhere in between for me.
Yeah, so I've used Kotlin and Kotlin.js before to build stuff, and the idiosyncrasies of deploying onto the JVM and deploying basically onto, what's the JavaScript engine in Chrome called? Someone help me out. No, not Node.js. It's called, anyways, V8, thank you, V8 Node. Just the sheer difference in deploying onto those two things. Sure, you're using the same programming language, but you might as well be using two different ones. You have to know so many little things about both the platforms to be successful at deploying an application into both. So,
but having said that, I'll give you one example where this was interesting. Though is a company that I was working with was training. They said they had to perform validation on the back end and validation on the front end, but the back end was Java, the front end was JavaScript. So they decided to use Kotlin to write the validator and then generate the validation code for both ends. So that was a small use case where that actually helped them. So there can be places where it's beneficial as long as you're able to control the environment. But as you mentioned, if it's really widely apart, it's going to be incredibly difficult to really get anything useful out of it.
All right, last question of the evening.
Hey, Venkat, nice to meet you. So, general question. What has been the most impactful version of the JDK, in your opinion?
What has been the most impactful version of the JDK?
Wow, I don't think I can pick one. That's why I'm struggling. One. I was going to say Java 8, but I don't want to just say Java 8 alone. So for me, definitely it was Java 8, personally. And the reason I'll say that boldly is I used to badmouth Java all the time. And I would go to conferences, I would say Java is not the language to use. I'm not even exaggerating when I say it because I saved these for later records. I used to get hate emails from people. And the emails would say, I hate you, Venkat, because you hate Java. And so I've saved them away. It's nice to see these. And so Java 8 was the language that turned me around to Java. And honestly, I remember, I could never forget this. I remember telling myself, I don't care about Java. Big deal, Java has lambdas. I've used lambdas in other languages. I don't care about it. And I remember coming back from trip, sitting at my home, and I saying, oh, let me just take a look at Java's lambda after all. And I dig in, I looked at streams, and I literally, I'm not exaggerating when I say it, I literally stood up at my desk.
And started clapping.
No, started writing the Java 8 book. I immediately, it took me only 10 minutes. I said, oh my gosh, this is different. And I sit down and wrote the book in 2 weeks. And I wrote this 2 years before Java 8 was published, was released. I was so convinced that Java 8 was going to be a big deal. So to me, that is a biggest change. But I keep changing this over time because to me, Java 9 is a significant change people have not understood yet. I call Java 9, I relate Java 9 to parenting. When I wrote the book on Java, Cruising Along with Java, that's exactly the words I used. Sometimes when you're a parent, the children don't appreciate what you do for them until decades later. Most people don't agree with this today, but I think modules are exactly that. Everybody hates modules, but we just haven't realized how powerful modules are. So for that reason, I think Java 9 is significant. Moving further, almost every release of Java has been contributing something interesting, but Java 20 for me is virtual threads. Is going to be huge for that reason. And I would say in different viewpoints, each one of them is significant. From a programmer point of view, Java 8 is the most significant. From multi-threading point of view, Java 5 was, in terms of the executive service, right? That was very significant. From a point of view of the ecosystem, Java 9 modules were significant. Scalability and deployability point of view, I think Java 20 is going to be significant.
And let's not forget AI in Java 18 with the new vector API. So
it depends on the viewpoint, I think.
All right. So I think we're going to wrap
Can I
things
ask
up.
one punny question?
Yeah, as long as it's a good pun.
Okay. Now, I have to ask this. I'm going to quote my inner Nate Shuda. How many times a day do you say when you're consulting, it depends?
Not as many times. The reason is it gets tiring hearing that. And I have to tell you this, Glenn. We were constructing a house, and we are the people telling it depends all the time. So we were constructing a house, and there was a guy fixing stuff, and I went to him. I've never met him before, and I asked him a question, and his answer was, it depends. I'm like, damn it, I tell that to people. You don't tell that to me now, right? So, yeah.
All right, everyone. Thank you for coming out. We hope you have happy holidays. And let's give a big round of applause for our guest speaker tonight.